Introduction to Induction, Understanding Inductive Reasoning and Mathematical Induction. Hello, everyone. Welcome to our lecture on Introduction to Induction. We are going to look at induction covering both inductive reasoning and mathematical induction. What is induction? So let's start by defining induction. Induction is a method of reasoning or proving statements. There are two primary types of induction. The first is mathematical induction, which is a proof technique used to establish the truth of statements involving natural numbers. The second type is inductive reasoning, which involves making generalizations based on specific observations or examples. And both forms of induction uh, plays crucial roles in mathematics and everyday problem solving. Principles of mathematical induction. So in order to prove that a statement, let's say statement is P of n is true for all natural numbers, we can follow two main steps. Say first, we will have the base case where we prove the statement for an initial value, usually 0 or 1. And then second, the inductive step where we show that if the statement holds for an arbitrary case k, it must also hold for k plus 1. If both steps are successfully proven, we can conclude that the statement is true for all natural numbers. So if we look at this Python code, we have defined a function called sum natural numbers, and it receives n as a parameter, and this calculates the sum of the first n natural numbers using the formula n times n plus 1 divided by 2 using integer division. And we can look at the function and test it with different values to see the base case and the inductive step. So for the base case, n is 1, and we can see that the function correctly returns 1. For the inductive step, we can check that the function works for n as 2 and n as 3. Example of mathematical induction. So let's see an example. For this example, we try to prove the formula for the sum of the first n natural numbers. So we are proving that 1 plus 2 plus 3 plus dot 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 plus n equals to n times n plus 1 divided by 2 for all n greater than or equal to 1. So for the base case, we check n equals 1. We can see that by replacing n with 1, this holds true. And for the inductive step, assume that statement is true for n equals k, So we will have 1 plus 2 plus dot 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 plus k equals k times k plus 1 divided by 2. And now we need to prove this for n equals k plus 1. So we have 1 plus, if we replace this, we will have 1 plus 2 plus dot 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 plus k plus 1. And if you take a look at this, this turns out to be k plus 1 times k plus 2 divided by 2, because we're replacing k with k plus 1. So the first k becomes k plus 1, k plus 1, because we're adding 1 to it, it becomes k plus 2. And since we know that the base case and the inductive steps are true, the statement is proven for all n greater than or equal to 1. And if you look at this Python code, we have a function called induction sum that computes the sum of the first n natural numbers using the formula that we talked about. And here we can quick by using assert quickly check the base case inductive step for specific values of n being 1, 2, and 3. And we have another function called prove induction, and this function checks both the base case and the inductive step for the n given. And we know that by providing 3 for prove induction, we know that the output comes out to be true. Please feel free to try other values for n. Applications of mathematical induction. So mathematical induction has several applications. First, it's widely used in proving algebraic identities. For example, summation formulas and properties of factorials. Second, it helps in proving divisibility properties. So like showing that certain numbers divide others. And lastly, mathematical induction is really important in algorithm analysis, specifically in proving the correctness of recursive algorithms. So these applications highlight the importance of induction in various mathematical and computational fields. And this is example in proving the correctness of recursive algorithms. So in this Python code, we define a recursive function called factorial, and it receives n as a parameter. And we compute the obviously factorial of n, and we can then test the function with values 5 and 6, for example, and we can see that output shows the correct results. So induction can be used to prove that this function correctly computes the factorial for all non-negative integers. Example of divisibility proof. So let's try to prove a divisibility property using induction. So let's first look at the statement. We aim to show that 3 to the nth power minus 1 is divisible by 2 for all n greater than or equal to 1. Then for the base case, we check n equals 1. So we will replace n with 1. Then we will get 3 to the 1's power minus 1. And this comes out to be 2. And we can verify that 2 is divisible by 2. And for the inductive step, we will assume the statement is true for n equals k. Then we will replace n with k. So we first have 3 to the kth power minus 1. And we are going to assume this to be true. Then we're going to prove it for n equals k plus 1. So we will replace n with k plus 1. So we have 3 to the k plus 1th power minus 1. And this comes out to be 3 times 3 to the kth power because this plus 1 could become 3 in coefficient. And then we could change this so that it is 3 times 3 to the kth power minus 1 plus 2. So since we know that 3 to the kth power minus 1 is divisible by 2 by the inductive hypothesis, and we know that 2 is also divisible by 2, so the statement holds for n equals k plus 1. So by induction, 3 to the nth power minus 1 is divisible by 2 for all n greater than or equal to 1. And we have this Python code. We define the function divisible by 2 that accepts n as a parameter. And this function returns true if the expression is divisible by 2 and false otherwise because of this modulo 2 equal 0. So here we are testing the function with n being 1, 2, 3, and then output shows that the statement holds true for these values. So we are showing that both the base case and the inductive step works. Inductive reasoning. So inductive reasoning involves drawing general conclusions from specific observations. So for example, if we observe that the sun rises every morning, we might conclude that it will rise again tomorrow. Also, say we notice that a plant grows toward light, we may infer that all plants grow toward light. And this type of inductive reasoning has its strength and limitations. On the strength, or on the positive side, it allows us to formulate hypotheses and theories and make predictions. However, the conclusions drawn from inductive reasoning may not always be true as they are susceptible to counterexamples. And if we look at this code, we have this Python code that illustrate reasoning by observing patterns in a list of numbers. So this function is pattern continuing, calculates the difference between consecutive numbers in the list and checks if they are all the same. The output shows that the pattern continues for the given list, demonstrating how inductive reasoning can be used to make generalizations based on specific observations. Common pitfalls and tips. When using induction, there are common pitfalls that you want to be aware of. One major pitfall would be forgetting the base case, which is important for the foundation of the proof. Another is making errors in the inductive step, where the logic must follow correctly from the inductive hypothesis. And you also need to consider edge cases, since overlooking edge cases can also lead to incorrect conclusion. And in order to avoid these pitfalls, make sure you clearly state the base case and inductive hypothesis, and make sure that the inductive step is detailed, and not only is detailed, but also logically progresses from the hypothesis. And also, you want to make sure that all possible edge cases are covered so that the proof is comprehensive and accurate. Conclusion. So induction is a really powerful tool in both mathematics and everyday reasoning. It is important for proving statements about natural numbers, but also making generalizations based on observations. And to strengthen your understanding, it is important to practice. So make sure try proving by using induction. So you can try proving that, for example, the sum of the first n even numbers, n even numbers meaning like 2 plus 4 plus 6 plus dot 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 plus 2n equals n times n plus 1 for all n greater than or equal to 1. If you actually look up online, there are a lot of problems, a lot of exercises related to induction. So I highly encourage you to take a look at those. Thank you everyone for listening.